there. We can slide on over to example 3. And again, we're going to do the same thing. We have our function here, and that is continuous as long as we're putting values into the log that are positive. It's going to be defined there. And we are. We're on a closed interval. So our first step is to go ahead and find the derivative of our function. And that is something I would just prefer to go ahead and distribute and then take the derivative of. That's just a personal preference of mine, so I'm going to do that. So now the derivative of 20x is 20. And then we're going to have minus 10 times, I'm taking that constant times a function out, so minus 10 times, it will be the first times the derivative of the second, plus the second times the derivative of the first. So that's going to be 20 minus 10. Let's clean this up a little bit. That's going to be 1 plus natural log of x. And distributing the minus 10. So that's going to be 10 minus 10 log x. That is our derivative. And we're going to want to set the derivative equal to 0. So we have 10 minus 10 log x equal to 0, adding 10 log x to each side. Sorry about that. And then dividing both sides by 10. And log of x is equal to 1, where x is equal to e. So now we're ready to go ahead and we have our critical point at e. 10 minus 10 log x, that is defined everywhere on our original closed interval, so we don't have any places where the derivative's undefined. And then we do also have the endpoints to go ahead and evaluate. So when we plug in e to the original, that's going to be 10e times 2 minus natural log of e. Natural log of e is 1, 2 minus 1 is 1, so this is just going to be 10e, something a little bit bigger than 27. We plug in 1, and we're going to get 10 times 2 minus natural log of 1. Natural log of 1 is 0, so this is just going to be 2 times 10, or 20. And if we put in e squared, our square there we can bring down here. Log of e is equal to 1, so that is going to turn out to be 0. So our value here, let's change colors, is going to be 0. So that's going to be our max. That's going to be our minimum. So we have an absolute maximum of 10e at x equals e. And we have an absolute minimum of 0 at x equals e squared.